Prakash from the Department of Physics and Electronics, K.B.N. College. Okay, on the series of the paper titled Optical Instruments and Optometry, this session is related to the second unit called telescopes. So first unit is related to the microscopes and all, and the second unit is all about the telescopes. What are the types of telescopes are there, how they are classified, what are the advantages and disadvantages it is having on other telescopes regarding that. So this paper, in this unit, we are going to cover different types of telescopes like refracting telescopes, reflecting telescopes, and what is an astronomical telescope, how it can be constructed, and what is the working principle behind the astronomical telescope. And then we are going to see about the what is a terrestrial telescopes, what are the different types of lenses that are used in terrestrial telescopes, and at the last we are going to see about the binoculars, what is the working principle behind the binoculars. Okay, so first of all, what is a telescope? So the telescope, from Galileo, first glimpse of the moon to modern space exploration, telescopes has been revolutionized and our understanding of the cosmos. So let's discover the remarkable instruments, that how they work. Let's see how they work, how the telescopes will work. So coming to the telescopes are classified into two types, like refracting telescopes and reflecting telescopes. Refracting in the sense, when a light ray passes from it can easily passes from one medium to the other medium with some deviation is known as the refracting telescopes. Otherwise, if a light ray will hit say some optical instrument and hit back into the same medium, then it is known as the reflecting telescope. This is a major difference between the reflecting and refracting. So coming to the refracting telescopes, the refracting telescopes uses lenses to bend light from one to form this image. They use lenses. It is one of the oldest type of telescopes. It is used to observe moon, planets, stars, galaxies, etc. This refracting telescope are used to observe the celestial bodies. So this is how it is used. And coming to the construction, this is how it is also called as the refractor. This type of telescope. It has a long and lengthy tube in which we have a convex objective lens. Here we have two types of lenses. One is this objective lens, and the other one, this is called as the eyepiece. Okay, this long tube will have one convex objective lens and one eyepiece at the back of the view where we can able to see from it. And the objective lens will collect the image from the source. It collects the image and it forms the image at the eyepiece, near the eyepiece. That image will act as an object for the eyepiece lens. Okay, this will act as an eyepiece lens. The eyepiece magnifies the focused image, sets up the arranged into a straight line. Okay. Coming to the working, the refracting telescopes views the image. The distant light enters the objective lens first. Okay, the objective lens will form certain image which is in the range of focal length of the eyepiece lens. So the image will be formed here, like you can see here. The image will be formed here. Here we can, this part will become the image for this eyepiece lens. Okay, so here the rays from this will enter into the objective lens, and the objective lens will form the image over here. The image here will become the object for the eyepiece lens, and after passing through the eyepiece lens, it will be viewed by the observer who is observing it. Okay, the eyepiece will enlarges the image what they are seeing. It will make it larger and it will be viewed by the observer. The final image will be of inverted and it will be more magnified than the real image. Okay, coming to the uses. These refracting telescopes are used in astronomy, like in order to view planets, stars, etc. It is used in binoculars or spy glasses. It is used by the Galileo for space studies. Okay, for used to observe the space studies, the refracting telescopes are generally used. Coming to the reflecting telescope, this quietly opposite of the Refracting telescopes. In refracting telescopes, we use the phenomena of refraction, but in reflecting telescopes, we will use the phenomena of reflection. This reflecting telescopes uses mirrors instead of lenses to collect the light. Okay, in refracting we uses lenses, but here we are using mirrors. Okay, mirrors. Why? Because it will reflect the light. Okay, it is mostly used in modern astronomy. So coming to the construction of reflecting telescopes, here we have a concave mirror. Okay, it is called as a primary mirror. Here we have two types of mirrors called primary and secondary mirror. When the light enters this primary mirror, the light will be moved on to the secondary mirror, and the secondary mirror will get the reflected light back onto the eyepiece lens where the observer is viewing. This also will have a longer tube, but it will be somewhat shorter than that of the refracting lenses. Okay. Coming to the working principle, the incoming light coming from the far object will fall onto the primary mirror over here. The primary mirror, concave mirror, will reflect the light onto this secondary mirror, which is held at a 45 degrees angle. Here we can clearly see this incoming light will coming from a far object. It falls on this primary mirror, and this primary mirror reflects the light onto the secondary mirror, and this secondary mirror will reflect the light. Okay, it will passes through a convex lens, and it will act as an eyepiece. Okay, this eyepiece will magnify the image. The final image will be more bright and magnified, and it is often inverted. Coming to these uses, unlike refracting telescopes, reflecting telescopes are used in large observations. They are best for faint stars, galaxies, and nebulae, etc. It is used as a space telescope. Now, what are the major differences between these two things, refracting and reflecting telescopes? In refracting telescope, we will often use lenses, but in reflecting telescopes, we use mirrors to collect the light. Okay, refracting telescope works on the phenomena of refraction, and it works on the contrary. This reflecting will work on the phenomena of reflection. Okay. It suffers chromatic aberration, whereas refracting telescopes and this reflecting telescopes doesn't have much chromatic aberration. It will have a clear image. Why? Because it is not passing through any material. It is just the reflecting light from the other mirror, one mirror to the other mirror. Okay. Refracting telescopes forms the bright and nearby objects, but reflecting telescopes is best for faint and distant objects. Refracting telescope was invented by Galileo in 1600, but whereas this reflecting telescope was invented by Isaac Newton. These are the major differences between reflecting and refracting telescopes. Now there comes this astronomical telescopes. Astronomical telescopes, the name suggests it is used to study the astronomy. Okay. The optical instruments for using distinct celestial objects. This astronomical telescope is best preferred because it produces magnified, virtual, and inverted image. It is mainly used by astronomers to observe how the planets are moving, how the stars are illuminating light, like that. Coming to the working principle of this astronomical telescope, it works on the refraction of light using two convex lenses. One is objective lenses, and the other one is the eyepiece lens. It is having the same working principle as the refracting telescope. Why? Because these are using two convex lenses, right? One is objective and the other one is eyepiece. The eyepiece image, the eyepiece, where the observer is viewing, it will magnify into a virtual enlarged image at infinity. The final image will be a strain-free image for the eye, where the observer can see it more easily. So the same principle, like it has a long tube, it will have two objective lenses. One is an objective lens and the other one is the eyepiece, and it is also called as the refractor. Coming to the working principle, the parallel rays coming from the large object will fall onto this long tube, where one convex lens will be placed, which is called as an objective lens, and it will become and this image where it is formed by this convex lens will become the object for the eyepiece lens. Okay, the eyepiece will form a virtual enlarged and inverted image at infinity, which will be comfortable for the observers to see. Coming to the applications, applications of astronomical telescope, like to observe moons, planets, stars, etc. It is used to observe the features of celestial bodies. Okay, astronomical telescopes often used in schools, colleges, observations, etc. It helps understand universe very well. These astronomical telescopes. Coming to the magnifying formula, it is given by magnifying formula is equal to f naught by fe, where f naught is the focal length of the objective lens and fe is the focal length of the eyepiece. Terrestrial telescopes is the second type of telescopes now we are going to see in this session. These terrestrial telescopes used to view distant objects on Earth like ships, mountains, stars, birds flying, like that. It produces magnified and virtual upright image. Terrestrial telescopes used for ground-based observations. They used for like not usually often to observe the long distance bodies like other like celestial bodies. They are used to observe only the ground level bodies. Coming to the principle, it works on the principle of same as the refraction, where it will have two lenses, like one is objective and the other one is the eyepiece lenses. The objective lens forms an inverted image which will be extra enlarged, and this will become the image for the eyepiece lens. This eyepiece will magnify the corrected image. Construction, where we'll have a long convex lens which is more bigger than that of the astronomical telescopes, and it will have an erecting lens in the middle, in between this convex, in between the objective lens and in between the eyepiece will have an erecting lens in the middle. It will make the image to erect the light. Okay, next we will see how it works. Okay, these lenses will be fitted in a long cylindrical tube, and this longer tube due to the to extract the lens. Okay, this is how it will work. Okay, this is the lens which is called as an objective lens, and this will cause an erecting lens, and this is the eyepiece. Here you can see the light is coming from the far object. After passing through this objective lens, here the first image is formed. How here you can see it is a inverted image and somewhat a diminished image, and this will become an image object for this erecting lens. What the erecting lens will do is it will make the image upright. Okay, here you can see the image formed by the erecting lens is an upright image and somewhat slightly magnified, but this convex lens, which is called as an eyepiece, will form an enlarged image. Okay, the final image will be clear, erect and magnified. Coming to the working applications, the applications of terrestrial telescope will be birds watching. They are used for bird watching, wildlife, navigation, etc. They are used in travel, exploration, surveillance, etc. It is used in military and sports uses, and it is mainly helpful for students and hobbies, like used to watch sports and etc. like that. And it is used in military to observe the far enemies so clearly. The final thing, magnifying power, it is the same formula of this astronomical telescope, f naught by fe, where m is the magnifying power and f naught is the focal length of the objective length and fe is the focal length of the eyepiece. The last topic is binoculars. So binoculars, we are familiarly known to observe the objects like hobbies. They will use on the neck to observe this thing. Okay, it is based on the refraction of light through lenses and prisms. Okay, convex objective lenses forms the inverted real image. They will form. Okay, binoculars will have a pair of prisms, like poro or roof. They will invert the image upright. Actually, here terrestrial telescope we have seen will have an inverted image, and it will be inverted by this pair of prisms. Then the eyepiece lenses will magnify the final image, and it will have two tubes here, which allows the light to pass into both the tubes, and it will be like a 3D effect, and it will have a very depth. The images will be very depth, like we are seeing as if it is so real and as if it is so near to us. to us. These will be adjustable lenses. They will have a screw on this one as well. Coming to the applications of binoculars, so it is well used for bird watching, nature observation, what is going on around, like that. They're used for military and security surveillances to see the enemies or other persons, and this is used in tourism as well to observe the long distance bodies, and it is used in sports like in Wimbledon, etc. Badminton, in order to see how they're playing like that. Okay, thank you for watching.